All right, Math 2. So covering what we're basically doing this week, it's going to be a little bit of a shorter video. This week is basically sort of your EO9 cumulative assessment. So we don't have any new content. It's basically just going to be a mix of everything all together. The point of this unit is that at this point now, you can kind of just pull any one individual tool of these trig functions out and use them to basically find unknown information. That's where we want you to get to by the end of this. To be clear, we're going to drop the special right triangle properties, so that stuff where if it was a 45, 45, 90, hypotenuse was square root 2 times bigger, those sort of things. They're good to know, but now that you know how to basically work sine, cosine, and tangent, as well as undo them to find angles, you can get back to that same piece of information without having to have that portion memorized. Don't forget all that SOHCAHTOA stuff. That's going to come in handy. It's going to come back in a big way in Math 3 for sure. And some of these assessment details that we're talking about, I sent an email sometime last week that basically said this one is optional. And the reason I say that is we're going to basically take your 4 highest grades for all of these quizzes. You submitted your 961 yesterday, because that'd be Wednesday the 6th, so happened to be 9-6 on 5-6. At this point, you have your 9.1, 9.2, 9.4, 9.5. Those are all graded, and then you just did your 9.6 yesterday. If you're happy with your score, once I get those 9.6 ones graded, hopefully tomorrow, if you're happy with how it is at this point, great. You don't need to worry about taking this. You can leave it. If you think, hey, I can do better on this sort of final one here, we will drop the lowest one and basically have this replace that. So you'll see something in Infinite Campus for this. If you choose not to take it, that's the one that gets dropped because it'd basically be like a 0, right? So I sent a couple sort of example grade scenarios in those, and if you do it and you try it and it doesn't go as well, that's fine. Your 4 highest still count. So I want to cover a few things and just a little bit of thinking here, and then we'll let you get to your assignment. This is page 564, number 2. If I gave you an assignment or a question like this, we got this triangle here with a 20, a 16, and an x. What questions might you think could be asked? The first thing sort of that comes to my mind, I see that it's a right triangle. I have 2 sides, and I don't know a third, and it's labeled. My first instinct would probably be, let's find that side, right? And I'm just going to do a little bit of Pythagorean for it. Let's change this font size. So that's going to be 16 squared plus x squared equals 20 squared. Right, 20 is my hypotenuse. Let's go ahead and clean this up a little bit. 16 squared should be 256. X squared is x squared. 200 or 20 squared is 400. If I subtract that 256, that's going to give me 144 for x squared. And you take a square root of both sides, you're going to get x is now going to equal 12. So that's one sort of question. Now, where could you go further from here? In page 564, number 2, that's all it's really asking you to do. But at this point, you have all 3 sides. I could ask you to completely solve this triangle. You could go back and figure out these 2 angles, these other unknown angles. We have the 90. Since you have all 3 sides, you could use any trig function you want. I'm going to call this bottom left one A. If I wanted to find angle A, I'm going to show you how I would do it with 3 different trig functions. Okay, I'm just going to type out sort of the setup. If I were to do sine of A, that would equal my opposite side, which is 12, divided by my hypotenuse, 20. Take an inverse sine, just like we were working on last week. There you go. You're going to have your angle, no problems. I could, if I wanted to use cosine, that would now look like this. Cosine of A would have to equal to 16 over 20. And if I were to do tangent of A, that would equal my opposite, which is 12, over my adjacent, 16. So I'm going to pop into Desmos real quick to actually show that all of these things work. So we have what? Sine of A is 12 over 20, just to figure out this angle, right? Okay. We go to my inverse function, because I'm going to take the inverse. I have to put the side lengths into an inverse to get an angle out. I had 12 divided by 20. We see it's, because it's already in degrees, 36 point, let's call it 9. Great. That's what this guy right here is going to give me, 36.9. I could also do an inverse cos of 16 over 20 to find A. Let's do that one. Go to my functions, inverse cos of 16 divided by 20. Oops. Oh no, I pressed these wrong. Let's try that again. Inverse cos. Let's actually click the right buttons this time. And we get that same 36.9. And our last one was tangent of A was 12 over 16, so I could do inverse tangent, where the heck is it? There it is, of 12 over 16. I'm going to do inverse tangent of 12 divided by 16. Hey, it's 36.9 degrees. It doesn't really matter. Guys, hold on, guys. Like, why do you guys have to start when I make a video? Come on. There you go. Once you get that other angle, you can just do the 180 minus 90 minus that to find this guy. But like, even if I don't ask for that, your brain can kind of be telling you, hey, which one works best for you? How could you approach that? If I gave you this is page 564, number 8. What questions could be asked? I see that I've got an angle and a hypotenuse, and there's a label on from that angle, from that 30-degree angle, the opposite side we don't know. So I'm thinking, let's probably find x. Considering that it's opposite and I know the hypotenuse, that tells me I'm going to use sine. My current setup would be sine of 30 degrees. Oops. That just messed it up. There we go. Would equal x over 14. I'll do it a different way. I'll do it like this. X divided by 14. What am I going to do to basically now get, like, that's what I would, just looking at this, probably lean toward. If I were to solve for x, I'm going to multiply both sides by 14, because this is in the denominator here. Go to your calculator, type in 14 sine of 30. It should be 7. Let's see. 14 sine of 30. Yep, 7. So I now know this opposite side here. This is one that you could have realized, hey, it's a 30-degree angle. The short side is going to be half of the long. But that's what I'm saying. We're not worried about those anymore because I can set up a trig function and just do the algebra for it. You could now figure out what this guy's going to be. It'll end up coming out to 7 square root 3. But you could also do Pythagorean for it too, right? You could do 14 squared equals 7 squared plus this guy and solve for it. If I've got a 30 here, I can figure out this last guy's 60. Like this, at this point, you have so many pieces that you can start to just find all of the triangle. And that's why the last section was solve a right triangle, figure out every piece of information. We've got page 566, sort of example 9.5 here at the top. We've got a triangle ABC where it has all 3 sides labeled. I've got a 16, a 30, and a 34. We could ask what is maybe angle B or angle A. And because you have all 3 sides, just like we did 2 slides ago, you could figure out with any trig function. You could use sine, cosine, or tangent. The question here is not even so much going that far. It's, we're going to ask you something this week. It's basically going to ask the following things. I'm going to type them all out. What is sine of A? I want to know what cosine of A is. You can probably guess what's going to come after that. Tangent of A. Then I'm going to want to know what sine of B is. And then cosine of B. And to finish it off, tangent of B. Basically, can you give me every single possible variation on these? I wouldn't do any with C because that's the right angle. None of the trig functions we're going to use are going to use that right angle. It's always going to be just these other 2. The right angle and the triangle allows us to use these. I'm going to go through and just write in these answers here. If I'm looking from A, my opposite is 30 and my hypotenuse is 14. So that's going to be, I'm just going to type in here. 30/34. You can reduce it. I'm not super worried about it. What is cosine of A? Adjacent to angle A is 16, and the hypotenuse is 34. That's 16 over 34. Tangent of A is going to be the opposite side, which is 30, divided by the adjacent side, which is 16. Again, these are all reducible. I'm not super worried about it. If I were to now go to sine of B, the opposite side from angle B is going to be a 16, divided by the hypotenuse, 34. Cosine of B is going to be the adjacent, the angle or the side next to B is 30, divided by the hypotenuse, 34. And then tangent of B is going to be 16 over 30. And you might have noticed a couple patterns with these things in the past. I saw some people really good at these things, that if they knew sine of A, that was the same thing as basically cosine of this other angle. That's why you could do that, remember that 90 minus the other angle to find that piece. And we have these two sort of match up, cos of A and sine of B. However, you might not have yet noticed this, that if you do tangent of the other angle, it's going to be the reciprocal. It's going to flip the fraction. The reason that is when we change the angle, we're changing the orientation of opposite and adjacent. If I'm looking from angle A, 30 is opposite. But if I now go to B, 30 is adjacent, and what used to be opposite becomes, or adjacent becomes opposite. It's just going to flip. You don't have to worry about that, just an interesting fact. If I give you a triangle and say, can you list all 6 of these trig functions and their ratios? We're going to expect you to be able to do that. Something like this, page 566, number 16. We've got a 23-degree angle. I've got 2 sides labeled T and S. I have a hypotenuse that's 34. We're probably going to ask you to find sides T and S. Now, this problem, if we do that, it's really one step away from just solving the right triangle, finding all 3 sides and all 3 angles. I've got a 90, I got a 23. Even though it's not labeled, I could figure this out real quick, right? If I take away the 90, that's going to be 90. 90 minus 23 is going to be, what, 67 degrees? So I've already got all 3 angles. Let's go ahead and figure out these 2 sides. I'm not going to use the 67 because the actual question says find T and S using both sine and cosine. It wants to see that can you set that up. It's going to look like sine of T is going to equal, I'm sorry, sine of 23 because that's actually the angle. It's going to equal T, the opposite side, divided by 34. What am I going to do to get both, or T by itself? I'm going to multiply both sides by 34, which is going to give me this. 34. Type 34 sine of 23 in a calculator. You've got that side length, right? That's just, can you hit buttons on a calculator? To find S, it's basically going to be the same setup. But now that S is the adjacent side, I need to change sine to cosine. Change this T to S. Right? It's really the same process. Multiply both sides by 34 to get something that's going to look like this. Oops, didn't do that right. There we go. Type it in a calculator. You can figure out those values, but it's the thinking that I'm more concerned about with this, right? I'm not concerned about anyone's ability to jam those numbers in. Dogs, can we just wait? Hold on. No, I'm not trying to play right now. In a moment. Okay, last one, just because it's been maybe a little while for this. Page 567, number 15. One of these guys where if we give you this ratio, we're giving you that cos of theta is 5 over 7. Just wanted to remind you with these guys. I don't know if I said it. Page 567, number 15. Draw a right triangle and then start labeling pieces. Okay, I'm drawing in my right angle. I'm going to put theta down in my bottom right corner. It doesn't really matter as long as it's not your 90. Cosine is a relationship between adjacent and hypotenuse, meaning I know my adjacent is 5, my hypotenuse is 7. If I want to know what sine of theta is, I don't actually have to figure out this angle. You could. You now know this, right? I could do inverse cosine of 5/7. Hold on. Dogs. Come on. Oh, come here. Can we just joke a little bit? You guys going a little wild. You got some. Okay. You could absolutely figure out the angle, but that's not what we're asking for. I want to know what the sine ratio and tangent ratio are based on this information. This is one where it's basically just a spicy Pythagorean theorem problem. You know two sides. I have a hypotenuse and a leg, and I need to find another leg here. In this case, from here, it's the opposite, which makes sense because sine needs the opposite side, and so does tangent. Cosine gives me adjacent and hypotenuse, so I have the hypotenuse that I already need for sine. I have the adjacent I need for tangent. Both of them just need that opposite. So let's solve it. To find that unknown, actually instead of x or question mark, I'll call it x. So do some Pythagorean. X is a leg in this case. I'm going to do x squared plus 5 squared equals 7 squared. This one's not going to be the prettiest number, and that's okay. It's going to be x squared plus 25 equals 49. Hey, guys, chill. It's okay. I'm going to go outside in just a second, I know. Subtract the 25 from both sides. What's that going to give me? Let's see if I can actually do the subtraction today. I've been having issues with some of that. 9 minus 5 is going to be a 4. 4 minus 2 is going to be a 2. So what's x going to be? This is a weird one. It's not pretty. Square root of 24. You could type it into a calculator and figure it out, and it's going to be like 4.9 something. It's going to be way up there, I bet. Or you can just leave it as the square root of 24. I'm going to do that for right now. So what's sine of theta going to be? Well, sine of theta, let's go ahead and retype this. I'm actually going to copy it because that character is hard to get. Come on. Why are you guys talking? You're fine. What are you making noise about? Come on. I don't know if you hear them in the background. My apologies. All right, sine of theta is my opposite side, which we just found is a root 24 over my hypotenuse, 7. No need to clean that guy up. It's fine. Tangent is opposite over adjacent. We just found the opposite was root 24 divided by the adjacent, 5. We are going to give you one of those just because that's a good sort of logical thinking skill with all these pieces. That's kind of what I got for you for the week. You'll see a big ideas practice assignment. I will have another did you watch the video check survey coming out here. And watch out for information about finals next week. It's going to be, again, all level 2s. We're not quite certain how many questions it's going to be yet. It will serve as a retake for EO 6, 7, and 8. So that was the quadrilaterals, similarity, and polygons. It's not going to have any EO, or the final will have EO 9 stuff on it, but it's not going to be a retake because this one's been split in so many different ways. The grading for that's a little bit different. If you have questions about how this test for this week works, please send me an email. And the dogs are basically telling me that I think that's sort of the time for today. So, thank you. I hope you're safe and well. Goodbye.